I am 3 honors student. It's Miss Mack, and today we are going to do section 9.7 and 9.8. We're going to find values of polynomial functions and learn about the remainder and factor theorems. So first you'll see on my paper that I have the remainder theorem. And you can copy this down if you want. It's in the book if you don't want to copy it down, and there's a much more formal thing in the book. But the remainder theorem says if the polynomial f of x is divided by a linear binomial of the form x minus a, then the remainder will be f of a. That means if you were to divide by the value a, the remainder will be the same as if you were to plug a into the function. And that's it. So we're going to use that for example 1 in a minute. Then we also are going to talk about the factor theorem today. And what the factor theorem says is if the remainder is 0, if f of a is 0, then the binomial x minus a is a factor of the polynomial. So to check if something is a factor, you want to make sure the remainder is 0. And that's all it says. Here we go. Example 1, go ahead and copy down example 1. If you want to pause the video because you're not done writing at any time, just remember to do that and then get back on. So here we have, if p of x equals x cubed minus 3x squared minus 4x plus 12a, find p of 2. So in the past, you would just plug 2 in here and probably use a calculator to evaluate that. Well, today we are not going to use a calculator and we're not going to plug in 2. What we are going to do is use synthetic division. We're going to make 2 our box number. And we're going to take our coefficients and we're going to put them inside our box. So our coefficients are 1, -3, -4, and 12. And remember the rules for synthetic division. You add down and then you multiply by the box number. So that's the rules. Add down, multiply by the box number. And you remember that, you'll be good to go. All right, so we add down. There's nothing to add to the 1. 1 times 2 is 2. Add down, -3 plus 2 is -1. Multiply by the box number. Add down. Multiply by the box number. And the remainder is 0. So using the remainder theorem, that means that p of 2 equals 0. So that's how you evaluate the value of a polynomial function using synthetic division. We're going to do the same thing for part B, except this time we're going to find p of 2i. So we're going to do the same thing we just did, except our box number this time is going to have an I in it. So what's that going to look like? It's going to look like this, 2i. What were our coefficients? 1, -3, -4, and 12. And then our rules are the same, add down. There's nothing to add to 1, so we bring it down. 1 times 2i is 2i. Excuse me. We're going to add down -3 plus 2i. We're going to multiply that by our box number. So -3 times 2i is -6i. And 2i times 2i is 4i squared. I'll just write that over here for a second for you to see 4i squared. 2i times 2i is 4i squared. Now you need to remember that I squared equals -1. So this is actually going to be -4. Okay. And I did that off to the side so I didn't make this too messy. Now, when you add down, you have to combine like terms. So the number portions, -4 and -4, make -8. And the 6i doesn't have anything to add to it, so -6i. And I write the real number first and then the imaginary just because I was trained very well by my algebra teachers in high school. All right, we're then going to multiply this by our box number. Negative 8 times 2i is negative 16i. Oops. I tried to square it. Sorry. Negative, come on. Negative 16i. And then negative 6i times 2i would be negative 12i squared, which is going to be just a positive 12. So when we add our like terms together, 12 plus 12 is 24, minus 16i. That is our remainder. That is our remainder. So what that means is P of 2i equals 24 minus 16i. And that's our answer. So now you know how to evaluate a function using synthetic division and the remainder theorem. This even works for other ideas and other types of problems. So here we have another type of problem in example 2. So I'll give you a second to write that down, or you can pause the video. Example 2 says find m so that p of negative 1 equals 6, given p of x equals x cubed minus mx squared minus 4x plus 12. So what we are going to do here is we are going to set up synthetic division just like we would on any other problem. Trying to decide what color to use. All right, so what is our box number going to be? Our box number is going to be our negative 1. What are our coefficients going to be? Our coefficients are going to be 1, negative m, negative 4, and a positive 12. Okay. All right. We do synthetic division the same way every time. Add down, multiply by the box number. So 1 times negative 1 is negative 1. When we add down, these are not like terms. Negative m minus 1. We multiply by our box number. That's going to give us an m plus 1. We add down. That's going to give us an m minus 3. We multiply by our box number. That's going to give us a negative m plus 3. And when we add down, we get negative m plus 15. That is our remainder. That is our remainder. And what we learned by the remainder theorem is the remainder is the same as evaluating the function at that value. So negative m plus 15 is the same as 6. And when two things are the same, we set them equal. So negative m equals negative 9, so m is 9. And that is our answer to number 2. There are other ways to do this problem, but that's probably the most straightforward. All right, we're going to go on to example 3. Too many papers on my desk. All right, example 3. Example 3 says to find the zeros of f of x equals x cubed minus 3x squared minus 4x plus 12. So you have lots of tools in your toolbox, mathematical toolbox anyways, to solve this, or not really solving, but to figure out what the zeros are. You could try factoring, you could try P over Q. So you have lots of different options when you look at this problem. And my favorite way to solve a polynomial, if possible, is factoring. And we haven't done this type of factoring since the very first day of chapter 9. So I think it's a good idea that we review it. And when it has 4 terms like this, we can try and factor by grouping. I don't know if you remember that. Factor by grouping. And so that is what I am going to do. So I'm going to group these first 2 together, and I'm going to pull out their GCF. What do they have in common? They have an x squared in common. And so when I divide that x squared out, I get x minus 3. Then I'm going to ask, okay, what do these next two have in common? And remember, when the leading one has a negative, it starts off with a negative, it's best to factor that negative out. So I'm going to factor out a negative, and then 4 goes into both of those. And when I divide that negative 4 out, I get x minus 3. Now for factor by grouping to work, these two binomials need to be the same. If they're not the same, you either did something wrong or you can't factor by grouping. So notice that those two factors are the same. So that's their GCF now. So I'm going to factor that out. When I factor it out or divide it out, what's left? So if this divides out, I have an x squared. If this divides out, I have a minus 4. So I've started my factoring process, and then I see if it can factor some more. Here I still have a quadratic. It's actually a difference of perfect squares, so I know it can factor more. And it can factor to be x minus 3, x minus 2, and x plus 2. So if I'm finding the zeros, I want to set those factors equal to 0. And so I'm going to get x equals 3 and plus or minus 2. So those are my zeros. If you didn't remember to use factor by grouping here, you could always use what we learned in 7.3 last week, which is the P over Q. But I like factor by grouping. Totally up to you. All right, let's look at number 4. You're going to want to know how many examples there are today. There's quite a few. So example number 4 says we're going to divide this polynomial by x minus 4. So go ahead and write it down. And we are going to divide x cubed minus 3x squared minus 4x plus 12 by x minus 4. And so here we have a choice. We could use synthetic division, or we could use long division. I think I'll review long division with you just because we haven't done one in a while, but realize you could use synthetic division here as well. So I'm going to use long division. So that means I'm going to put x minus 4 on the outside, and on the inside, I'm going to put x cubed minus 3x squared minus 4x plus 12. All right. So I think we did this, was it in chapter 7 in quarter 1? It was a long time ago. So remember, you want to turn this x into an x cubed. So you do that by multiplying by an x squared. So you take this x squared and you multiply it by both pieces here. You're going to multiply x squared times x and get x cubed. You're going to multiply x squared times negative 4 and get negative 4x squared. And then you are going to subtract, which changes these two signs. It's the most common mistake. This first term always needs to come out to be a 0. Here you're going to have negative 3x squared plus 4x squared, and that's going to give you 1x squared. I'm just going to write x squared. And then what do you do next? Well, you need another term, so you bring down the negative 4x. At this point, you need to figure out what goes right here. So you need to make an x squared. You have an x. So what do you need to multiply x by to make an x squared? You need to multiply it by a positive x. Positive x times x will give us x squared. And a positive x times a negative 4 will give us a negative 4x. And then you subtract, which changes both of these signs down here. And that is going to give us a 0 and a 0. Well, that doesn't look great to some people. Now they don't know what to do. So you bring down your 12. And you can't multiply x by anything. That'll give us a 12 here. So this is our remainder. And so what do we do with our remainder is we bring it up here. We add it because it's positive, and our remainder is 12, and we put it over our divisor, x minus 4, like that. So our answer to this problem is x squared plus x plus 12 over x minus 4. Hello? Yes, it is. Okay.